This is your next question. This is from vectors. I'll give you the rough diagram. You're given a parallelogram. And the name of the parallelogram is given as O, A, B, C, and OA. This is the direction given is equal to A, OC is equal to Z. And given that X is the midpoint of the line AC. So let me join that AC. And the midpoint is marked as X. And OCD. So I have to extend this. Let me call a point over here as D. OCD is, yeah, it's given that OCD is a straight line, so that only this much is given. OC to CD, it's in the ratio K is to 1. And given that XD, the vector XD, this is XD. I'm joining that. This vector XD is 3C minus half A. 3C minus half A. We are asked to find the value of K. This is what we have to find out. So to find the value of K, we have to find these distances. Means OC and CD. OC is given as C. So we have to find CD in terms of C. Only then we can equate it with the ratio K is to 1. If we want to equate this, you have to find the length of OC and CD. OC is, we have it as C, and CD you have to find out. Okay, so to find CD, we have to get the value of this vector. This vector is, here it is given, this is half of AC. XC is half of AC. So first you have to find AC, then find half of AC. From that you can find CD and find it in terms of C, and making it into ratio, you get the value of K. So this much things you have to perform. So the first what we have to do, we have to find AC, this vector AC. So AC is equal to, I can write this as vector AC. See, AC, this is a vector. So I'm starting from A. That is equal to vector AO plus vector OC. I have to find AC. So that is equal to vector AO plus OC. But see, the direction of A is in the opposite direction. So I have to put a negative sign. So this is equal to negative A plus C. Okay, so we got AC. And it's given that X is the midpoint of AC. If X is the midpoint of AC, this midpoint divides this equally. So this will be half of this. So vector XC is equal to half of vector AC. Now vector AC is equal to, this is equal to half of negative A plus C, which I can write as C minus A. Both are the same. C is positive, A is negative. So I wrote it as half of C minus A. Okay, now I got XC. XC is half of C minus A. Now see, XD is given. XD is equal to 3C minus half A. And this XC is equal to this value. So if I add this and this, I can equate it to XD, means XC, vector XC plus vector CD is equal to vector XD. This is vector XD. This is vector XC, CD. So XC plus CD is equal to XD. XC we have already calculated. Vector XC is equal to half of C minus A plus CD. CD we have only the ratio. It's in the ratio K is to 1. So if this is C, some multiple of this I can take. So that I can write it as XC. CD is equal to XC, which is equal to XD is given to be 3C minus half A. Now I solve for this. See, this is equal to half C minus half A plus XC is equal to 3C minus half A. I have a negative half A here. So those two got cancelled. Now what remains is this XC is equal to 3C minus half C. C is common. So I'm cancelling C also. Now I get the value of X. X is equal to 3 minus half. I can write it as 2.5, or which is equal to 5/2. So X is equal to 5/2. We have taken CD as XC. Okay. And the value of X is 5/2. So CD, vector CD is equal to X times C. X is 5/2 times C. So now I can equate this ratios. CO is equal to C is to 5/2C is equal to K/1. C and C, I can remove the C and C. Means 1/5/2 is equal to K/1, which means that, see, I have written it is in the fractional type. So C/5/2, C and C gets cancelled. C is both there in the denominator, cancel. So 1/5/2 is equal to K/1, which implies that K is equal to, what is the value of K? K is equal to 1/5/2, which means that that is equal to 2/5. So you got the value of K as 2/5.